This is the review for the Chapter 16 quiz. So the first thing that you want to do before you even start is always make sure that your stat diagnostics button is turned on. So remember, you won't get R values if you don't turn on the stat diagnostics. So make sure that you go to your mode button, go all the way down, and make sure that your stat diagnostics is turned on. So when we take a look at question number 1, the table below shows the daily sales of a boutique since the first day of the month. So we have 0 through 20 here, and we're skipping some numbers. Notice that. And so we're going to graph these. So we have 0 and 1750. Again, this is going to be a scatter plot. It's not going to be a connect the dots type thing. 1 and 1635, 2 and 1550. And these are just approximations. 3 and 1450, 4 and 1400, 5 and 1350, 10 and 1225, 12 and 1275, 15 and 1400, and 20 and 1800. So I can sort of see that it looks like a U-shaped graph. All right. So what type of regression is this? It is clearly quadratic. All right. You can tell that just by looking at the picture. It does not form a straight line. It is U-shaped. So again, explain your choice. It's because it is clearly a U-shaped graph. Write the regression equation. So when you go to do this, you need to type in your data into your L1 and L2. We do that by going to Stat, Edit. I already typed in my data here. Always double check your data to make sure that it is correct. Now we need to do the quadratic regression. So Stat, Calc, and then quadratic regression, remember, is number 5. So we're going to hit 5. We want our L1 and our L2, so we're going to go down to calculate and hit enter, and magically it does its work. So remember, this is what the quadratic equation looks like. Y equals ax squared. So the directions say round to the nearest hundredth. So I'm going to have y equals, I'm going to put my a value rounded to the nearest hundredth is 5.38. Make sure you don't forget to type in your x squared after that. Then plus our bx. Now, I'm actually going to put minus 103.77. I'm going to put minus because it is a negative there for your b value. Don't forget your x after your b value. And then plus our c, so plus 1733.91. What is the value of the correlation coefficient? Round to the nearest 10,000th. So our R value is 0.99. And when you round to the nearest 10,000th, this would be 0.9965. How much will they save after 25 days? So after you have your equation here, you need to type it into your y equals. To save a little time, I already typed it into my y equals. So now that it's in my y equals, I can hit second and table and go all the way down to 25. So I'm going to keep on clicking, go all the way down to 25. Another way to do this one is to sub in the 25 in for x squared and in for x, and then figure out your number. So 5.38 times 25 squared minus 103.77 times 25 plus 1733.91. The easier way is just to go to your table. Now, be very, very careful, all right? It looks like it is 2502.2, but remember, the calculator only has a certain amount of space in each cell. So you have to tab over. Now I can see that it is 2502.16. So make sure that you tab over and it'll tell you the actual number in the bottom part of the calculator. G is a little bit tricky. After how many days will there be $1,300 in sales? So what we have to do, since we have our equation typed into our y equals, we need to graph it and find the intersection point. So when you go to graph it, all right, you won't see the graph. All right, we need to hit zoom and then 0. 0 is zoom fit. All right, zoom fit makes the graph fit on your screen. So when we go to zoom fit, now all of a sudden we see the graph. If you hit other buttons, the calculator is just going to spin and spin and spin. If you try and zoom out, it's never going to work. All right. So we need to know where 1300 is. So we have to go back to y equals, we go down and type in a second equation. We want to know when y equals 1300 because we're actually subbing in a 1300 for the y. Now, when we graph it, you can see that there's an intersection point at 1300 at y equals 1300, but I need to know what that x value is. So I'm going to go to second and calc. I want to find the intersection point of those two. So 5. And then first curve, yep, it's on the blue one. Yep, it's on the red one. Guess, hit enter again. And notice that my x value now says 6.129. So rounded to the nearest tenth, this would be 6.1. For question number 2, Sherry travels to her friend Marcia's house, stays a while, then returns home. The graph shows her distance from home for the duration of the trip. Question A says, state the time interval where Sherry's rate of change is 0. So rate of change being 0, it's not changing at all right? She's not going anywhere. She's not traveling. She's standing still. So in interval C right here, she is standing still. Notice that the distance is not changing. That distance not changing is a key to showing you that she's standing still, that she's not moving. Her rate of change is 0. In question B, is she moving faster in segment B or D? Justify your answer by comparing the rates of change. We need to use the slope formula. Segment B goes from the point 0, 0 to 1.5 over to 1.5 up to 12. So we need to find the slope or the rate of change going from 0, 0 to 1.5 comma 12. That's how we're going to find the rate of change for B. For segment D, we need to find this slope. So starting at 3.5 comma 12. And we're going to the bottom here, which is 5 comma 0. So now we need to plug those numbers into the slope formula. The slope formula is y2 minus y1 over x2 minus x1. Remember, all points are written x comma y. This is your first point, so these get 1s. This is your second point, so these get 2s. This is your first point, these get 1s. This is your second point, these get 2s. We need to sub the numbers into the formula where they belong. So y2 minus y1, we're going to have 12 minus 0. x2 minus x1, 1.5 minus 0. When we subtract these, we get 12 over 1.5. When you divide that, you actually get a rate of change of 8 exactly. y2 minus y1, 0 minus 12. x2 minus x1, 5 minus 3.5. When we subtract, we get negative 12 over 1.5. Negative 12 divided by 1.5, top divided by bottom, is negative 8. Now, be careful. That negative 8 doesn't mean that it's slower, all right? 8 and negative 8, these are actually the same, all right? We actually have to take the absolute value of that number because she's not traveling at a negative speed. It's just that she's coming closer back to home, all right? That's what that negative means, that she's getting closer. So these are actually the same. So these would be equal. Normally, you would take the larger of the two numbers is the faster rate of change. But when they're equal like this, because of the problem, it's negative because it's going down because she's coming closer back to home. In question number 3, you have a table for car depreciation. They want to know which regression equation best models the data. Well, what you want to do is, again, type in your numbers into your stat edit. All right, so I already did that, 0 through 6, 36 through 0.5. What you want to do is the one that best models the data has your R values that are closest to 1 or -1. So what we need to do is we need to do this is a linear equation. This is clearly a quadratic equation. I can tell that because of the x squared. And this is an exponential. I can tell that because of the to the x power. So we need to do each one of those types of regressions and see which R value is closest to it. Remember, you have to have on your stat diagnostics. So trying out choice A, when I go to stat calc and number 4 for linear regression and do my calculations, I can see that it has an R value of -0.8965, and it has an R squared value of 0.8038 if we round it. Doing your quadratic regression for that same data. I'm not changing the data at all. I'm just doing a different type of regression. So I'm going to do number 5, which is the quadratic regression. And when we do that, I can see that it has an R squared value of 0.9881. For the exponential regression, to see if that one is the best, I need to go to stat calc and then 0 for exponential regression. When I go and do that, I can see that it has an R value. I can see that it has an R value of -0.9987, and it has an R squared value of 0.9975. So you want the one that's closest to 1 or -1. So the one that's closest, I have 0.8s. Obviously 0.9s are closer, so it's not going to be A. When I go and look at this one, I have 0.98 compared to 0.99. That one is definitely closer, so it would be choice C. One of the sort of hints to this, you might want to graph that data. If you want to graph this data, remember, to graph a scatter plot, you have to go to second and stat plot. You need to turn your stat plot on. All right. When you go to turn your stat plot on and hit graph, then you'll see the data. I can see that this looks like an exponential curve. So that would be a good indication that it's probably exponential. But you do need to find all of your R values by doing stat calc. In question number 4, which correlation coefficient would indicate the strongest correlation? Remember, the strongest is the one that's closest to 1 or -1. The one that's closest to 1 or -1 would be 0.999999. This one is closest to 0. That's not the right answer. We want 1 or -1, so this would be choice D. In question number 5, the table shows the number of thousands of runners in a marathon over the years. Now notice that you're given years. Remember, we don't type in specific years. Years always start with 0. So 1990 is really year 0. 1991 is really year 1. 1992 is year 2. And then this would be year 3 and year 4. And year 5. Now be very, very careful right here. Notice how they try and trick you. 96 would be year 6, 97 would be year 7, 98 would be 8, 99 would be 9, 2000 is actually 10, 2001 would be year 11, 2002 would be year 12, 2005 would actually be year 15, this would be year 17, and this should be year 20. So those are the numbers that you need to type into your stat edit. So I've already gone through and done that. Again, you don't type in specific years, all right? You don't type in specific years. What type of function would best model the data? So again, we have to go through and do our different R values, find our R values to see which one fits the best. So stat calc, we're going to try the linear first. So number 4. And our R values for linear, R value is 0.9521. For our R squared value, it is 0.9065. For quadratic, stat calc. Number 5 for quadratic. We get an R squared value of 0.9986 or 87 if we wanted to round it to the nearest 10,000. Stat calc, number 0 for the exponential regression. And our R value is 0.9794. And our R squared value is 0.9592. So when you take a look at these, we're looking for the one that is closest to 1 or -1. This time it would be the quadratic. 0.99 is closest. Remember, you can always graph it to see the data. If you go to second and stat plot, make sure your stat plot is on and then hit graph. This one really doesn't show us much. All right. Maybe if we go to zoom stat, maybe it'll be a little bit better. There we go. So we can see that it sort of looks like it is quadratic. It would be a hard time deciding quadratic or exponential just by looking at the graph. That's why we always need to find your R values. In question number 6, what type of regression best models the data? So again, remember all points are written X, Y. So you're going to type in all of your X values like I did into my L1, and you're going to type in all of your Y values into your L2. So I already went ahead and did that. We want to know which one fits the best. So which R value is closest to 1 or -1. So let's try number 4, stat calc number 4, the linear regression. All right, for the linear regression, your R values are 0.0315 if I round, and -0.1774. That is for the linear. For stat calc number 5 for quadratic. For the quadratic, it is an R squared value of 0.9940. And for stat calc number 0, which is our exponential regression, we get an R value of 0.0422 and -0.2055. So which one is closest to 1 or -1? It would be the quadratic, which is this 0.99. 0.99 is closest to 1. In question number 7, we're using the same data from the previous question. So I already have that typed into my stat edit. So that's that same information. It says estimate the amount of sales in day 6. So we decided in the previous question that you're going to use a quadratic. All right, that was the type of regression that fit the data the best, that had the R value closest to 1 or -1. So we're going to go back to stat calc and we're going to do the quadratic to figure out your actual equation. So when we figure out our actual equation, we're going to go to stat calc quadratic regression. So our actual equation is y equals, we have 2.55 approximately for our A value when we round. Don't forget your X squared. And then we have minus 50.66X and then plus 801.46. So that is my quadratic equation that I'm going to use for this data. It's the same data from above. And so what I'm going to do is I'm going to go to my y equals. I'm going to type in that equation. And now I'm going to go to second and table and pick out number 6. All right. At six, notice that we have 589.3. So looking at our answers, notice it says about. So which one is closest to 589.3? Well, it would be choice A. All the other ones are farther away from it. For question number 8, the scatter plot represents the population of a certain animal species. for years in the years since 2005. What does the y-intercept represent? The y-intercept is this y-axis. All right, what does this represent? Well, what that y is that is 0 years since 2005. So this y-axis is really the year 2005. So this dot right here, I could say that I know in 2005, the population was 500. So I can tell exactly where that is. It is the population of the species in 2005. The y-intercept has nothing to do about how it's changing. It doesn't say anything about an exponential function with best model of the data. That's not answering the question. All right. The greatest recorded population of the species in the year since 2005. That is not what the y-intercept tells you. The y-intercept is where the line crosses the y-axis. All right. So this y-intercept right here, I know this population of the species in 2005. In question number 9, a construction worker needs to move 120 cubic feet of dirt by using a wheelbarrow. One wheelbarrow holds 8 cubic feet of dirt, and each load takes him 10 minutes to complete. One correct way to figure out the number of hours he would need to complete this job is. Now, notice that all the numbers are the same, but they're all, look, you have to look at the labels, all right? You don't have to actually figure out the answer, all right? Although you could. But what we want to do is look for things that are clearly wrong. We want to figure out how many, we want to figure out how long, all right? We want to figure out how many hours. So we want all the things to cancel out and have hours left over. Well, here in choice A, load and load would cancel out. Cubic feet and cubic feet would cancel out. But then we're left with minute times minute. We don't want minute squared. We want hours. So A doesn't make any sense. In choice B, we would have minute and minute that would cross out. But then we have cubic feet and cubic feet both on the same one. All right, that wouldn't make any sense. All right, those aren't canceling out because remember, we want it to equal hours. In choice C, we would have load and load that would cancel out. But then notice that we would have minutes squared across the bottom. And we'd also have cubic feet multiplied by cubic feet. We don't want that because of those. That doesn't make any sense. Watch what happens in the correct answer of D. Load and load cancel out. Minute and minute cancel out. Cubic feet and cubic feet cancel out. Notice across the top, all that we have left is hours. So we would have hours over 1. That makes sense because we're trying to figure out how many hours. And in this last question, a parking lot is 100 yards long. What is the length of 3/4 of the parking lot in feet? Well, the first thing that we would need to do is figure out 3/4. 3/4 of 100. So I'm going to multiply 100 times 3/4. You could change this into a decimal if you wanted to, all right? Or we can multiply it out by going 100 times 3/4 using the fraction bar or using the divided by sign as a fraction bar. We can multiply it like that as well. All right, 100 times 3/4 is 75. Now that is really 75 yards. Be careful. A lot of people would probably put choice C. It's not choice C. That's how many yards it is. All right. What we want to do is we want to figure out now and make that into feet. Well, there are 3 feet in a yard. So we would then have to take and multiply 75 times 3. 75 times 3 gives you 225. That's how many feet there are. So B would be the correct answer. So that's what your quiz looks like. There are a lot of calculator work. Make sure you always have your L1 and your L2 typed in properly. Don't forget that when it's a quadratic one, you need, if you go to type in your equation, you need the x squared and an x. Very common mistakes right there.